Hello, welcome to this video. I'm PDS the tutor. I'll be answering Mathematics Paper 2 GCE 2017. I'm going to post questions at the end of this video. Make sure you have your paper by your side as you are watching this video. So you have a question 1. I'll just answer from only section A. Question 1A says, given that k is equal to 10 and negative 2, 11 and negative 2, and says find the determinant of k. They are saying find the determinant. That's part 1. Part 1 says find the determinant of k. So how do we find the determinant of k? Determinant of k is equal to major diagonal, that is 10 times negative 2 minus 11 times negative 2. So 10 times negative 2, I have negative 20, minus 11 times negative 2, you have negative 22. Therefore, what you have is negative 20 plus 22. Discover that your determinant of k is equal to 2. You will find the difference there. That's how you find the determinant of a matrix. It's major diagonal, these elements, minus the product of the minor diagonal. So we have our determinant as 2. Let's go and answer the part 2. Then part 2 says find the inverse of matrix K. The inverse of matrix K is equal to 1 over determinant, which is 2, open brackets. Then these elements in the major diagonal, so the elements, this and this, they swap. So negative 2 goes there, then 10 comes there. While elements in the minor diagonal, 11 and negative 2, they change signs. So we're going to have negative 11 and there we're going to have positive 2. Then you multiply 1 over 2, then you multiply by the matrix inside. So we're going to have 1 over 2 times negative 2 is going to give you negative 2 over 2. And that will give you 2 over 2. This side will give you negative 11 over 2. And this side will give you 10 over 2. And what you have here is 2 into negative 2 is negative 1. 2 into 2 is 1. Here you have 11 over 2, because 2 can go into 11 to leave a remainder. Then 2 into 10 is 5. So that's the inverse of k. Question 1b says solve the equation 3z squared is equal to zz minus 1. Give your answers to 2 decimal places. How do we solve this one? So first we need to write this one in standard equation in the form of ax squared plus bx plus c. That's how we need to write it. So we already have 3z squared. This should cross the other side, becomes negative 7z. Negative 1 should also cross the other side to gain positive 1, and we have is equal to 0. This is how first we must write our equation. Then we can proceed into using this formula that says negative b plus or minus square root of b squared minus 4ac over 2a, and there we can replace the information that we have. So we have x is equal to negative, we have b. So in this case, before I go anywhere, we have 3z squared minus 7z plus 1. In this case, our a is 3, our b is negative 7, and our c is 1. So this is our c, this is our b, this is our a. So when it comes to replacing there, we'll say x is equal to negative, then negative 7 inside, because that's b itself. It's plus or minus square of negative 7 squared, that's b, minus 4. What is a? A is 3. What is c? C is 1. Then over 2. What is a? A is 3. Then we have 7 plus or minus 7, negative 7 squared will give you positive 49. Then negative 4 times 3 times 1 will give you negative 12 over, this will give you 6. So we can continue. Then we have, so what we have here is 7 plus or minus 49. Then therefore we find the difference. So I can lap the upper part if you don't mind, so that I can continue. So we have x is equal to 7 plus or minus 49. 49 minus 12 give you 37 over 6, and x is equal to 7 plus or minus, you need to find the square root of 37 first. You write it all. Here I'm having 6.08 276 253 divided by 6. So I can cancel this part. We already answered that. I have x is equal to, so there are two answers. It's either a 7 plus 6.08 or 7 minus 6.08. So if I add 7 to that, I'm going to get 13.08. Then I divide it by 6. So I'm going to have my first x is actually 2.1. And I'm saying to 2 decimal places only, so it's just 2.18. Sorry, not 2.18, but 2.12. Then the other x value is when I subtract 7 minus 6.08 276 253 divided by 6. That will give me 0.2. That's another value of x2. So that's how you find this quadratic equation. Let's go to question 2. Question 2 says simplify. That's question 2a. So question 2a says simplify. You have m squared minus 1 over m squared minus m. Now this is difference of two squares. What we have here is m minus 1, m plus 1. That's what we must know as a difference of two squares. Then here we can factorize, because m is common, we remain with m minus 1. And you can see that this and this is common. Then what remains with is m plus 1 over m, and the answer. Then part B, part B says the first three terms of the geometric progression are, we have 6, that is question 2b, sorry, 2b, 10 plus n, and 15 plus n. Question says find the value of n. Now this is GB. So B1, how do you find the value of n? To find the value of n in this case, we are going to use the formula for finding the common ratio of a geometric progression. Common ratio is term 2. In this case, our term 2 is this, our term 1, our term 3, over 6 plus 1, which is our term 1, which should also be equal to term 3, which is 15 plus n, over term 2. When you get those two, they're acting as first and second. When you get this, they're also acting as second. Then you cross multiply there. So we know what to do. So it's 10 plus n, multiplying with 10 plus n, which is equal to 6 plus n multiplied by 15 plus n. So 10 times 10 is 100. 10 times n is 10n. Another 10 times n is 10n. Then n times n, you get n squared, which is equal to 6 times 15. So 6 times 15, you get 90. Then 6 times n, you get 6n. Then n times 15, you get 15n. Then n squared, n times n, you get n squared. So now you can collect the like terms. You can see from there that it's n squared and this n squared, they're cancelling each other. Then you have 100 here, plus 10n plus 10n, you get 20n, which is equal to 90, plus 6n plus 15n, you get 21n. Therefore, we can continue. I'll lab the top part that we can answer properly. So we have 100n, 100 plus 20n. Then from there we can collect the like terms. We have 20n. Then there's also 21n here. Will come this side, 21n, which is equal to 90. 100 will go the other side to do 90. We have negative 100. So 20 minus 21, you get negative 1n is equal to 90 minus 100, you get negative 10. So this is over negative 1 over negative 1. So n is equal to 10. That's the value of n. So that's how you find x or n. Anything as long as the geometric progression, you apply the formula for finding a common ratio or the geometric progression. Let's go to question 2b, Roman numeral 2. Now that we know what n is, therefore our first term becomes 6 plus 10. So our first term, we have 6 plus 10, which will give us 16 as our first term, comma. Our second term is 10 plus 10, which will give us 20. And our third term is 15 plus 10, to give us 25. So those are the terms that we have. So our first term is 16, our second term is 20, our third term is 25. Now they're saying find the common ratio. Common ratio is equal to second term divided by first term, the same way we did in the previous example. So we have second term, in this case, is 20 over first term is 16. This should also give you the same answer when you divide 25. When you say 25 over 20, that should also give you the same answer. We know that 4 can go into 25 times. Also 16 can go into, 4 can go into 16 4 times. So that is your common ratio. Or if you want, you can say 25 over 20. 5 can go into 25, how many times? 5. And 5 can go into 20, how many times? 4. So it should also give you the same, when you get the third term, you divide by the second term, it should give you the same common ratio. So in this case, our common ratio is 5 over 4. Or in other ways, you can put it in form of a decimal number, which is 5 by 4, give you 1.25. Sorry, give you 1.25. So the other one says find the sum of the first 6 terms of this sequence. So you are finding the sum, the first 6 terms of the sequence. So from there, you know that the sum of the first 6 terms is given by a, open brackets. Now in this case, our r is 1.25, and you know that in this case r is greater than 1. So what we are going to use is we'll start with rn minus 1 over r minus 1. So our first term in this case is 16. R is 1.25. N is 6, which will be given minus 1 over r is 1.25 minus 1. So if you punch this on the calculator, you are going to find that 1.25 to the power 6 minus 1, you multiply that number by 16, we're going to get 45.0. Then you have just a minute. So as we get 45.0, let's say you have 1.25 minus 1, you get 0.25. And you divide 45.0 divided by 0.25, 45.0 divided by 0.25, we're getting 80. So the sum of the first 16 terms is actually 80. So let's go to question 3a. Question 3. Remember, the paper we are doing is 2017, paper 2 GCE Mathematics. Question 3a says, in a box of 10 bulbs, 3 are fault. So you have total of 10 bulbs. This is a total. Then out of 10, 3 are fault. Let's say 3 are fault. Let's use F. 2 bulbs are drawn at random, one after the other. Find the probability that. So they are taken one after the other. That means this is without replacement. That means the 7 are good. So we can use G. So 7 are good. So what happens is, when you are picking in the first selection, you have 3 of the fault ones out of 10. Also in the first selection, you have 7 of the total ones out of 10. But in the second selection, if you pick the same color, you're going to have 2 over 9. And here, if you pick the same color, you're going to have 6 over 9. But if you pick 2 different colors, you are going to have, for example, if I pick fault and good. Of course, fault in the first selection, it will be 3 over 10. Then good, it will be 7, but over 9. This is what you must know. So in this case, we are going to draw a simple tree diagram so that you can understand what this actually is about. So we have something like this. We have fault and we have good. Then since there are 2 selections, you are going to have this as well. Fault, good. Then we have fault and we have good. So in the first selection, we had fault, which is 3 over 10. Then good, it's 7 over 10. We assume if we picked both fault, we are going to have 2 fault remaining, then over total 9. But if you picked fault and good, the good remains 7 because this is its selection first. So, but the total in the second selection has already been disturbed, it's 9. If you picked good and fault will remain the same, 3 over 10. But if you picked good and good, you have 6 over 9. So from there we can find the 3a Roman numeral 1, which says find the probability that both are good. So probability of GG. Now both in probability means multiplication. So we have GG. So if you picked G here and G there, we are saying it's 7 over 10 times 6 over 9. So 7 times 6, it's 42, and 10 times 9 is 90. You know that you can reduce this. 2 into 42, you are having 21, over 2 into 90, you're having 45. Is it possible that 45 can be divided by 3? Yes. We can still divide this. So 3 into 21 will give you 7 and over 15. So that's the probability that you are picking good and good. What was the probability of picking where one is fault, which is part 2, Roman numeral 2. One is fault and the other one is good. So they're saying one is fault while the other one is good. So here we don't know whether at the beginning we have a fault one or a good one. So we're going to assume that we have a probability of good and fault, or we have the probability of fault and good. So we don't know which one is at first. So we can't just say no, just pick one. So we have probability of good and fault. So we have good and fault. That is 7 over 10 times 3 over, here sorry, it's 9 here, over 9. Or means addition in probability. Then F 3 over 10 times G now is here where we have 7 over 9. You can see that we are having the same there. Having 21 over 19 plus 21 over 19. Then a common denominator there is 90. How we are going to have 21 plus 21. Then I can lap this side so that I can finish working it up. So we have 21 plus 21 is 42 over 90 So we're going to get the same which we got at first, which is 7 over 15. So that's the probability. Let's go to question 2b, which says the Venn diagram below shows tourists attraction visited by students in a certain week. Find the value of y if 7 students visited Mambirima Falls only. Now when you look at the question, it says Mambirima Falls only. Mambirima Falls only has got 2y. So before I go anywhere, when they say something is just around, let me draw a cell, a Venn diagram. Let me call this 1, 2, 3. Let me call this x, let me call this y, let me call this one z. When I say find the elements in y only, I mean the only 2. Alright? If I say find the elements in x only, I mean just one here. Only the elements found in here. Only. Not here, not here, not here. So we have this question. In the question, I'm sure I can see it if you have a question paper by your side. Mambirima Falls only, we have 2y plus 1. Now they're saying this is equal to 7. So this is part 1, Roman numeral 1. We have 2y is equal to 7 minus 1. 2y is equal to 6 over 2 over 2. We have y is equal to 3. That's the value of y. So now you can see that the Venn diagram has been completed. It's now looking like this. If you have a question paper with you, we have 6, we have 2, we have 10 there, we have 4, we have 8, we have 1. Then we have 2y plus 1. So y is 3. So 2 times 3 is 6. 6 plus 1 we get 7. So this is Victoria Falls, this is Mambirima, and this is Gonya. So Roman numeral 2 says how many students visited Victoria Falls but not Gonya? So how many visited Victoria Falls but not Goma? So how do you answer this type of a question? So let me just erase this. So I'm saying only those who visited Victoria Falls but not Gonya. When you look at Gonya is here and Victoria Falls here. So those who visited Victoria Falls, we are going to only to get this part and this part only. These are part of Gonya, also these are part of Gonya. So you only have 6 plus 2, which is going to give you 8 students. Don't forget to put the quantity. So you have 8 students, that's part A of 2. Then B says 2 tourist attractions only. So 2 tourist attractions, it can be Victoria Falls or Mambirima, or it can be Mambirima and Gonya, or it can be Gonya and Victoria. So we're talking of the intersection in this case. We're going to have 2, another intersection is 1, another intersection is 4. We're going to have 7 students. Then C says 1 tourist attraction only. So we don't know where is Victoria alone, Mambirima or Gonya. So we're talking of 6, 7 and 8. And when you add 6 plus 7 plus 8, aggregate to get 21 students. So make sure you solve properly and understand what the question is asking you to do. So we'll end on question 4. So question 4a says x plus 3 over 5x minus 2 over x plus 3 as a single fraction in its simplest form. So for us to solve this one, we need to find the common denominator, and in this case our common denominator will be the same what we have down there as our common denominator, because we can't find the exact common denominator. We need to multiply the two. So if we divide this into here, you can see that these are cancelling. I'll remain with x plus 3. So I need to multiply x plus 3 times 3 there. So I'm going to have 3 here. You should work out this one the way I'm writing. Don't do shortcuts. Then I have 2 remaining. I can see that when I divide this one into here, this and this one they're cancelling. I remain with this one. So this one must multiply with 2 there. So I have 5x minus 2. Then we continue working out with our common denominator. 5x minus 2 x plus 3. Then I'm going to expand. 3 times x is 3x. 3 times 3 times 3 is 9. Then I'm having negative 10. I'm having positive 4. I'll just bring you this side so that we can work out properly. So we have 5x minus 2. We have x plus 3. Then 3x. So we need to collect the like terms now here. 3x minus 10x plus 1 plus 4. Then our final answer becomes 5x minus 2 x plus 3. Then 3x minus 10x is negative 7x. Then positive 9 plus 4, you get positive 13, and that becomes your answer. Question 4b says evaluate. You've been given to evaluate something like this. 5, then we have 2, then we have 3x squared plus 2x. So you've been told to integrate, then find the area of a curve. What this means is, if you have a curve like this, they want you to find area under the curve, in short. And in this case, what we have is a curve which is looking like this, where you have 2 here and where you have 5 there. Then it's something like that. Then we've been told to find the area under this. Remember, this is along the x-axis. So step 1, you need to integrate the function here. So first, integrate the function. To integrate is to increase the power, then divide by the new power. Then a constant gets an x, then plus c. Then 3 into 3 here, you get 1 to the power 3 plus 2x plus c. You've integrated. Step 2 is to find now the area. So you have, where there's x now, you put 5. Again, now you put 2. So let me just, so to find the area, you're going to say this would be x to the power 3 plus 2x, since we have differentiated, so integrated, then 5 there, minus, that's how you find x to the power 3 plus 2x to the power 2. Then where there's x, we put 5 this side, plus 2 to the power 5, like that, minus, here you put 2 squared plus 2x, and you work out 5 to the power 3, you get, 5 to the power 3, you get 125 plus 10, you're getting 135. So here you have 135 minus, you have 2 to the power 3, which is 8. 8 plus 4, you have 12. So 135 minus 12, you are getting 123. So this is 123 square units. Remember, this is area. So thank you so much for watching this video. I'm ending with question 6 and question 6 for construction. I will record the video specifically on that, on how to go about. So thanks so much. I'm PVS the tutor. I'll see you in the next video. Please, for private lessons, you can call, you can text me on 0978 07 60 90. So thank you so much for watching. I'll see you in the next video. Peace.